All right, so we're doing a very like this problem seems very basic from the get-go. Basically, you're calculating a library find based off an if statement, and then you're given the date, months, and year as values. So the first values are the return date, and the second are the due date. Return 9 times 15. The years are the same. The months are the same. The book is 9 times 15. Oh, okay. So 15 times number of days late. So first, let's add a comment for what the dates mean, just so we don't forget. And then we're just going to do an if statement one by one. I mean, I can't think of a better way to do it. So if year one, so the first values are the return date. So if the return date is less than or equal to, and yeah, so if it's less than or equal to the due date, and months is also less than or equal to the due date. Why did it do that? Less than or equal to the due date. And the day. Yeah, it needs to be all three. Yeah, because let's say the greater. If it's return on or before. Yeah, so we're going to do on or equal. What do you want us to return? Oh, return 0. Else. Oh, oops, forgot a colon there. Else return 10,000. Because that's going to be that's the very last case. And then we're going to add else ifs. See, so we can pass some of the test cases. These are the ones where, okay, so if the book is returned after the expected months, both in the same calendar year. If the book is returned after, but still within the same calendar months, how do you calculate the number of months late? Is it just only using M? Or do you account for D and prorate it? You know what? We're just gonna try using the difference in months, and then if that doesn't work, we'll prorate it. I have like a lot of hackos, so if I have to spend to buy a test case, no problem in my book. So let's add if the book is returned after the expected LF year one and the months is fine. I think this is good. I don't think we need to add the date is wrong, because if the data is right and this, yeah, because if this is met and the data is right, it would just go to this test case and return 0. So I think we can assume everything that goes here is already wrong in some regard to this query. And so by adding these two, it means that it has to be the date that's wrong. So this should be okay. And then we're going to do 15 times, and then D1 minus D2. Because the return date will be greater than, so that should be correct. Yep. And then we should pass even more test cases. So now the only ones we're not, why is this one taking forever? None of these test cases should take a while. I don't know why that is. So while we wait for that, yeah, while we wait for that to load, now we do LF. Because if the date is wrong and the months is correct, it would get caught by here. So now we can just do if the year is the same. Return 500 times M1 minus M2. This is a very, very like straightforward problem. Like they're not trying to trick you at all. And then this should pass all. Do you want me to prorate it? Is that why? Return 500. on the least precise. If it's returned, okay, let's unlock the test case. So input, so the year is the same, and the month is different. Why is the expected output 0? Date 2 is the return date. Oh. Right, because it's possible. Right, because it's possible you return it in a later month, but the date is higher. Okay. So, yeah, and so let's add a or statement here. So either they're both or the months is greater. Yeah, because if the months is greater, or months is greater, or year is greater. Yeah, because if the year is greater, then that also would be fine. Okay, so we didn't account for this. Yeah, so either the due date year is greater or the due date months is greater, or they're equal. That should fix, yep, that fixed all of it. Okay, so it was just, ooh, should have accounted for that from the get-go, but that's okay. 1,300 points. It's okay, slow and steady wins the race.